In this video, I'm going to represent complex number in the format of a polar environment. So first of all, let me remind you that in Cartesian system, complex number z is equal x plus yi, where x is our real number and y is our imaginary number. So if we draw it, right, I can draw in the complex plane when our x is a real number, real part axis, and our y is our imaginary portion. So if we have, for example, z is equal -3 plus 2y, that's going to be 1, 2, 3. This is a real portion, right? -3. And 1, 2. 2 is going to be our imaginary portion. I can put 2i. And the coordinate will give us radius vector. Why I say a radius vector, not just vector? Because it's a radius. It's always a vector for complex number, always gonna start from 0. That's important. Otherwise, it's gonna be just a vector that can start and end anywhere in the space. So this is radius vector. This is -3. In the Cartesian system, its coordinate gonna be -3 and 2. And to find the length of vector, radius vector z, let's say this vector, for example, this is our side A, this is our well, okay, let me use x and y. This is our y. This is our x. And this is our absolute value of z, because we are finding length. Length cannot be negative. So it's going to be equal using Pythagorean theorem, right? This is our right angle. So absolute value of z, or meaning the length of radius vector, it's going to be square root x squared plus y squared. Now let's move to represent the complex number in the polar system. So the polar system, we are operating with radius, right? If you don't remember, you can open the video where I talk about polar system with radius and angle theta. And here we have, this is our radius and this is our angle theta. Okay, so as you can see, radius is same thing in the polar system, matching to our absolute value of complex number z, right? So from here, what do we have? If I bring down here, make it triangle, right? And I have here, this is A. Let's say, how much is my A? 3. And this is my B, which is equal 4. Okay, so my radius vector, it's going to be equal absolute length of absolute value of complex number z, which is going to be equal. So here I had x squared plus z squared. Here I will have a squared plus b squared, right? Based on Pythagorean theorem, which is going to be equal 3 squared plus 4 squared. and we are getting here 9 plus 16, it's 25, and we are getting 5. Okay, so now tangent. So we could express r through length of complex number z. Now let's figure out the angle theta. So for angle theta, I'm going to take tangent theta first, because I am given A and B, right? So tangent theta is going to be the opposite leg, which is A, divided by adjacent leg, right? Divided by the adjacent leg, where theta is measured either in degrees or radian very often. So if it's given tangent theta equal A and B, to find theta, to find this theta angle, then I'm going to take inverse of tangent, which is going to be from here, inverse tangent of -1, which is gonna, I have to take that is equal B tangent, hold on, B over A, yes, inverse of tangent, it's gonna give me the angle itself, okay, which is we call argument. So R is our radius and theta is argument in the format of complex number. So now let's see how we are going to convert. So in this example, same picture here, in the same picture here, so I'm going to write down that in the form of Cartesian system, z is equal a plus bi, right? Actually, it's going to be opposite, but because my a is y, okay, let me write down. It's going to be the whole real portion, which is going to be b, and I'm going to put plus ai, because this portion is going to be our imaginary, right, vertical line, y-axis. All right, so from here, what else I can represent? So my b, my a in this case, from this graph, my a is going to be equal r sine theta, right? Because sine theta is equal opposite leg to hypotenuse. So here it is. Sine theta is equal opposite leg to hypotenuse. And from here, hypotenuse leg is equal hypotenuse times sine theta. In the same way, I can write down that cosine of theta, which is b, is going to be equal radius times cosine theta. And once I replace with this Cartesian format of complex number, I am going to get, this is going to be equal r cosine, r, where is my b? Yes, r cosine theta plus r I sine theta. Where from this I? Here we have this I, right? Z is equal B plus AI. A is equal R sine theta, and I, we have it there. So I'm taking this R out, And in parentheses, I'm getting cosine theta plus I sine theta, where R, we are going, this is our polar form of Z complex number. So let me rewrite. Z is equal R cosine theta plus I sine theta. Okay, this is in polar system, and this one is Cartesian system, and this one is in polar system. Okay, R, we call it magnitude, which is scalar value, magnitude. Okay, and theta is argument. Why we give some definition to R and theta? Because polar system operated by radius and angle theta. So if now we want to calculate the Z complex number or represent in the format, specifically, let's say this example, the A is 3, B is 4, represent in the polar system this complex number, I can do the following way. So I will need R and I will need theta. R we have, it's absolute value of Z complex number, which is 5, right? So I'm going to write down here Z is equal 5 times. Now let's go to cosine theta. To find cosine theta, I need to know theta. So if we look here, let me remind you, theta is equal tangent to the inverse version to -1 B over A. How much is our B? 4, right? Let me calculate here, do some drafting. So theta is equal inverse of tangent B over A, which is going to be tangent inverse of the tangent. B is 4, A is 3. Okay. So 4 divided by 3, and I'm taking in the inverse version of tangent. It's going to give me 53 point, approximately 53.13 degrees. Okay. Now I need to take cosine of this. It's going to be 0, the cosine 53.13 and plus I sine 53.13. If we want, we can calculate it, right? Take the calculator and find out how much is cosine 53.13 and sine 53.13, which it's going to be equal to the format of a Cartesian system. That is equal, how much is it? 4 plus 3i, right? 4 is the real portion and I is imaginary portion, which is we have 3. Okay, so we learn how to represent the complex number in the polar system and calculate. Okie dokie.